Okay, this is Calculus 2, April 16th, 2020. I have been asked to do a problem involving partial fractions or something of the sort. I picked a nice evil one. Okay, the last video I made involved a polynomial long division. This does not because we have an x squared up top and an x to the fourth down below, but we need to split this up. First thing we need to do is we need to factor the bottom. So we get x squared times x squared plus 3. And then we need to make a fraction for every single power of every single factor in the denominator. Now we have a factor of x, so we need to have something over x and something over x squared. Now the factor counts as x, that's a degree 1, x to the 1 power, so we just have constants up top. But the other one is an x squared plus 3, and so we have to have something of 1 degree, that's of degree 2, so the most general thing of degree 1. Oh my goodness, I really did come up with an evil one, didn't I? Oh, and there's more evil coming, I know that. Anyway, so here we go. So so we have x squared, so we have something over x to the 1, something over x squared. We don't have to make this a bx plus c because the factor itself is the x. So then we recombine it. Let's see, the a is going to need an x to make the x squared and an x squared plus 3, so it's going to be a times x squared plus 3. And then the b, it's got an x squared down below, it needs an x squared plus 3. Oh man, really? And then the cx plus d needs the x squared. And down below we have the x squared plus 3 dx. Now, what we need to do is we need to find a, b, c, and d that make this numerator equal to this numerator, because as you can see, they both have x to the fourth plus 3x squared down below. Yikes. Well, one thing to do is we could multiply it all out, have all the x squareds add up to 1, all of the constants add up to 3. Actually, that's not too hard, actually. Hopefully you can see what I'm doing. If I multiply this all out, there's going to be x's in it. If I multiply this all in it, there's going to be x. Go with 3cx cubed dx. The only constant is, let me write that out. The only constant is going to be the b times 3, 3b. See, these a, b, c, d, they're all numbers. So this is going to be a x cubed 3ax is 3b, and the only constant over here is negative 3, and therefore 3b equals negative 3, b is negative 1. Bang! That is information. That is useful information. What's another thing that we could throw in here? Ah, man, there's nothing I can do to make the x squared plus 3's go away. And if I plug in 0, I'm going to get very, very little. I'm going to get the b. Ah, this is awful. Okay, so we've got the integral of, I'll multiply it all out, ax cubed plus 3ax. We know b is negative 1, so minus x squared minus 3 plus cx cubed plus dx squared all over x squared times x squared plus 3. That has got to equal x squared minus 3 over, okay, so over x squared minus 3 over x squared plus 3 dx. So what have we got? No, this is dx squared. Let me just double check this. A times x squared a cubed, a 3ax, yes. B is negative 1, so this is minus x squared minus 3, and then cx cubed dx squared. Okay, now we have 1x squared over here, and over here we have dx squared minus x squared. That's the only x squareds we have. So that tells me that the coefficients, d minus 1 has got to equal 1. D minus 1 equals 1. That means D equals 2. Well, that's nice. What else do we know? We know that the x's, we know that there's no x's over here, And over here we have 3ax, and that's it. So that tells me that 3ax has to equal 0, so a equals 0. And the x cubes have to be the same. So on the left we have ax cubed plus cx cubed equals no x cubed, but a is 0, so that tells me that c has to equal 0 also. So then we put this all together. Where did we have? What did we have? We had the integral of, what was it, x squared minus 3, x squared minus 3 over x to the fourth plus 3x squared dx. We said that was a over x, but a is 0, b over x squared, b is -1, -1 over x squared. Cx plus d, c is 0, and d is -1. No, d is 2. Plus 2 over x squared plus 3 dx. And if we multiply this all out, watch this, we multiply this all out, we're going to multiply this one by x squared, so we can check. And we get, what is it? This is -x squared minus 3 plus 2x squared all over x squared times x squared plus 3. If we multiply this one top and bottom by x squared plus 3 over x squared plus 3, and this one by x squared over x squared, and then this is going to cancel out to be just x squared minus 3. It does check out. So what do? This is the integral of, negative x to the -2 dx. Now this one is awful. I said it in, why did I come up with awful at the end of all of this? This one, it's just a power. It's not natural log because, what was that? It's not natural log. It will be x to the -1 over -1 with a -1 in front, which cancels out. And then over here, so that's just 1 over x. But over here, it's so close to tangent, it's not tangent. It's going to be tangent-esque. But I'm going to do it with trig sub. I'm going to say x is, I want x squared plus 3 to be a nice thing. Tangent squared plus 1 is secant squared. I'm going to use square root of 3 tangent of theta. Dx is square root 3 secant squared of theta. So this whole thing becomes 2. The dx is, d theta. Up top we have root 3 secant squared of theta d theta. Down below, x squared plus 3 is going to be 3 tangent squared plus 3. The 3 will factor out. Tangent squared plus 1. I'm having to fix this. I had just said tangent squared plus 1 is secant squared, and I thought that was just secant. I'm so used to square roots of these things. Nope. This is 2 root 3 over 3. We have secant squared of theta d theta up top, and tangent squared plus 1 is secant squared of theta. So these secants go away entirely. At least one person was sort of in despair about this because we have 1 over x plus 2 root 3 over 3 integral of d theta. What the heck is the integral of theta? Well, that's basically a 1. And so this becomes 1 over x plus 2 root 3 over 3 theta plus e. If it was just 1 dx, the integral would be x, but 1 d theta becomes theta. And then, let's see, we said tangent of theta is x over root 3. So this becomes 1 over x plus 2 root 3 over 3 tangent inverse of x over root 3. I had said that sort of 1 over x squared plus 3 looked a lot like 1 over x squared plus 1, which is arctangent. Well, the integral of we had a 2 in front of it, but other than that 2, the integral of 1 over x squared plus 3 is going to be root 3 over 3 arctangent of x over root 3. Not something I know off the top of my head, so I do that with trigonometric substitution. Again, hopefully this showed the sort of complications and the integration by parts, how you can break up a fraction, and then a little bit of some of the more tedious trig sub kind of stuff that we're doing all the time now. Enjoy the day.